I audible and is my screen visible? Can anyone let me know?
Yes, you're audible.
Okay, thank you. So good evening everyone, welcome to this NPTEL live session for the NPTEL course Introduction to Machine Learning. My name is Ayan Maiti. I'm a PhD scholar in the Department of Computer Science and Engineering at IIT Kharagpur. This is the week 9 live session. So in this live session we will discuss some practice problems on week 9 topics, mainly on Bayesian networks and undirected Bayesian networks. And if you have any questions or doubts regarding any of the topics, you can ask me, and I will try to answer your questions and queries. So we can start solving some practice problems first, and then if you have any questions or doubts, you can ask me. So this is the first question. This is on Bayesian network. Consider the Bayesian network shown in figure 1. Here in the left hand side, the Bayesian network is shown with 5 nodes, and two students, student A and student B, make the following claims. That student A claims that probability of A given B and D is equal to probability of A given D, and student B claims probability of A given B equals probability of A. So based on this Bayesian network in this figure, two claims are made by the two students, that probability of A given B and D equals probability of A given D. This is the first claim, and the second claim is probability of A given B equals probability of A. Then which of the following is true? There are 4 options. Student A and student B both are right. Option B is student A is correct but student B is incorrect. Third option is student A is incorrect and student B is correct, and fourth option is both are incorrect. I've already got one answer from Pratik Tiwari. He is saying option 3, which is student A is incorrect and student B is correct. Okay, that was really fast. You can take your time. This is not a very easy question, so you can take your time and write your answer in the chat. Has anyone else found out the answer? Shankar Lal is saying option 3. Okay, so I've got two answers in the chat. Both the answers are option 3. So the correct answer is option 3. So both the answers written in the chat are correct. So first we need to understand how can we represent these two probabilities in this Bayesian network. Because we have to use this Bayesian network because the relations are shown in the Bayesian network between these nodes. So what is this first claim? So the first claim is probability of A given B and D equals probability of A given D. So this basically says that A and B are independent given D. So this is the notation that is generally used for conditional independence. A and B are conditionally independent given D. So this is the claim. So we have to verify it using this Bayesian network. This is the node A, this is the node B, and this node D here is given. So this is the there is only one undirected path from A to B like this via C. So we have to check whether this path is blocked or not. If this path is blocked, then A and B are conditionally independent. If this path is not blocked, then A and B cannot be conditionally independent. So the rule according to the d-separation says that if C or any descendant of C, in this case D, is given, then this path is not blocked. So C is not given, but any descendant of C is, if any descendant of C is given, so in this case D is given, D is a descendant of C. In that case, this path from A to B is not blocked at C. So this path is not blocked. So there is a path from A to B. So A to B, as there is a path from A to B, so A and B cannot be conditionally independent of each other given D. So this first claim is wrong, and then we have to check the second claim. So second claim is very much simple. So this is just you have to check whether A and B are conditionally independent or not, and no evidence is given. So now in this case A and B, we have to check whether there exists at least one path from A to B or not, and no evidence is given, and there is one path like this via C, and no other evidence is given. So this path is so no other independence, no other evidence is given. So that's why this path is blocked here. So according to the d-separation rule, let's say I, J and K, if this is the scenario that K has two parents I and J, in that case, if this K is not given, if K is not given, then this path is blocked. So this is the case. Here C is not given in this second claim, that's why this path is blocked. So there is no path from A to B in that case. So A and B are conditionally independent. So the second claim is right. So this is based on the third rule of the d-separation rules for the conditional independence, because there are two parents A and B for the same child C. So you have to apply the third rule of d-separation, that if C or any descendant of C is given, then the path is not blocked, and if C or any descendant of C is given, then the path if not given, then it is sorry, 1 minute. If C and or D is not given, in that case this is blocked, but if C and or D is given, then this path is not blocked. So that's why the first claim is not right, second claim is right. That's why option 3 would be the correct answer. So is there any questions or doubt regarding this problem? Okay, so we can move on to question 2. This is again on Bayesian network. So this Bayesian network or the graphical model is given on the right hand side, and there are 4 options. You have to find out which of these following is or are true. There may be multiple correct answers in this question. First option is D is independent of B when C is known. Second option, A is independent of C when E is known. Option C is A is independent of B when E is known, and last option is A is independent of B when C is known. And there may be multiple correct answers here. Pratik Tiwari is saying A and D. Okay. Anyone else? Has anyone else computed the answers? So for this question we have to check each option one by one in the Bayesian network, and we have to check whether the option each option is correct or not. So first option says D is independent of B, so D and B, these two are, whether these two are independent or not, given C. So C is known, C is given. So if C is given, there is only one path from D to B, undirected path via C. So if C is given, this path is blocked here. So if there is no path from D to B given C, in that case D and B are conditionally independent. So first option is correct. Then second option says A and C. So A is here and C is here, and E is given. So it is similar to the It is similar to the previous question. If this D or any descendant of D, in this case E, is given, then this path is not blocked from A to C. So E is given, so this path from A to C via D is not blocked. There is a path from A to C, this path is not blocked. So in that case A and C cannot be conditionally independent. So second option is not right. Third option is A and B, A and B, whether A and B are independent or not given E. So if E is given, so if E is there is only one path from A to B, like this. So A to D to C to B, this is the only undirected path from A to D. We have to check whether this path is anywhere blocked or not. So if E is given, the path is not blocked at D, so ADC, this portion is not blocked. Now we have to check whether DCB is blocked or not. So the portion DCB, this portion is not blocked because C is not given here. So that means none of the portions of this path from A to B are blocked. So in that case this whole path from A to B is not blocked anywhere. So there is a path from A to B, so A and B cannot be conditionally independent given E. So third option is not correct. Then the fourth option, which says A and B given C, so C is given now. So there is only one path from A to B, A, D, C, B, this is the only undirected path. And if C is given, then this portion DCB of this whole path, this portion would be blocked at C, as C is given. This whole path from A to B is blocked because of C. So there is no undirected path from A to B. So that means A and B are independent of each other given C. So option D. So A and D, these are the two correct answers here. Suresh Kumar Singh has also written A and D. Okay, yeah. So these two are the correct answers. Is there any doubt in this question? So now question 3. Let's consider the following Bayesian network. A small network is given. This rain is for R stands for rain, S stands for sprinkler, and W stands for wet grass. These are the three variables that are used here. And these probability values are also written: probability of R, probability of S, probability of W given R and S, and then probability of W given R and complement of S, and probability of W given complement of R and S, and probability of given R complement and S complement. So these individual probability values are given, and from this Bayesian network you have to compute this probability of S given W and R. Has anyone calculated this answer? Pratik Tiwari says option B, which is 0.5. Okay, so in this question, you have to calculate is given W and R. So we can simplify this probability as WRS, probability of WRS divided by probability of WR. This is based on the definition of conditional probability. And then probability of WRS, for probability of WRS we can write it as W given probability of W given R comma S into probability of R into probability of S. So R and S are conditionally independent, so probability of RS we can write it as probability of R into probability of S. So that's why we can write the numerator like this. And then in denominator we can write it as probability of WR. This can be rewritten as probability of WRS plus probability of WRS bar or S complement. And then again we have to expand these two. I mean this probability of WRS would be same as the numerator, and you have to expand this probability of WRS complement similar to the numerator. It would be probability of so probability of WRS complement would be probability of W given RS complement into probability of R into probability of S complement. So all the values, individual probability values are known. So the first one, probability of W given RS, it is given here. Probability of R and probability of S, these are given here. And this probability of W given RS complement, it is given here. And these two are also given in this table. So all the individual probability values are known. As all the individual probability values are known, we can just plug these values into this formula and we can get the final result. That would be, I think the answer is C, 0.22. Pratik is asking RS is dependent. So R and S, if this weight gas, this value is not given, this weight gas of the W variable is not given, in that case R and S are independent.
Sir, but it is said like S given W and
Yeah, S given W and R, but when we expand it to this, so probability of WRS, we are probability of WRS, we are rewriting it as probability of W given R and S into probability of RS. So in I just want to expand this probability of R and S. In this probability W is not given, only probability of R and S. We want to expand this one only, isn't it? We just have to find out this probability value. So in this case W is not given, so in that case we can say that S and R are conditionally independent, so we can write it as probability of R into probability of S. So if R and S were not conditionally independent, we cannot write that. But in this case, the R and S are conditionally independent. Otherwise, this in this probability values given, we need to have probability of R comma S, which is not given because R and S are conditionally independent. So we can just multiply these two values and get that probability. So C is the correct answer, 0.22. Now we move on to question 4. What is the naive assumption in a naive based classifier? 4 options are given. All the classes are independent of each other. All the features of a class are independent of each other. The most probable feature of a class is the most important feature to be considered for classification. All the features of a class are conditionally dependent on each other. So what is the naive assumption that we make in any naive based classifier? Misty Pandey is saying option B. Raghav is saying option B. Suresh is saying option B. Pratik is also saying option B. Yeah, so most of you are saying option B, and option B is the correct answer. So for any given class, the features are independent. That is the assumption that we make. But it might not be correct for every task or every problem. So that's why this is a naive assumption or a very simplistic assumption that we make in case of naive Bayes in order to simplify the probability calculations. So that's why this is called naive Bayes classifier. This naive assumption is made that in a given class the features are independent of each other. Question 5. A spam filtering system has a probability of 0.95 to correctly classify a mail as spam and 0.10 probability of giving false positives. It is estimated that 1% of the mails are actual spam mails. Suppose that the system is now given a new mail to be classified as a spam or not spam. What is the probability that the mail will be classified as spam? Suresh Kumar Singh is saying option D, 0.0995. So for this question, we have to consider two random variables to make the calculations easier. So we can consider a random variable S, which stands for spam predicted by the system, and M, actually spam or actual spam. So S is when a mail is predicted by the system, and M is a mail being actually spam. So using these two random variables, we have to define these probability values that are given here. So first one is the spam filtering system has a probability of 0.95 to correctly classify a mail as a spam. So that means this is simply the probability of the given the mail is spam, what is the probability that it is marked or predicted as spam by the system. So this is probability of S given M. So this is 0.95. Then the second probability given is 0.10, probability of giving false positives. So false positive means those mails are classified as spam, but they are not actually spam. So the mails given that the mail is not a spam, it is predicted as the spam. So this is probability of S given M complement, and the probability is 0.10. And the third probability is 1% of the mails are actual spam mails. So that means actual probability of actual spam, which is probability of M, is 1%, which is 0.01. And using and we have to find out what is the probability of the mail, what is the probability that the new mail will be classified as spam. So we have to find out the probability of S. What is the probability of getting marked as spam for any new email? So we have to find out probability of S. So probability of S, how can we find out probability of using these three probability values that are given? So we can write it as probability of S given M into probability of M plus probability of S given M complement into probability of M complement. So probability of S given M is here 0.95, probability of M is given here 0.01, Probability of A is given, M complement is given here 0.01. Probability of M complement is 1 minus probability of M. So this is 1 minus probability of M, which is 1 minus 0.01, which is 0.99. So these are the values that we need. So all the values are already given. So if we plug these values into this formula, we will get option C, 0.1085. I've got two answers in the chat. Suresh and Pratik both are saying option D, but I think the correct answer would be C, 0.1085. Did both of you use the same method to calculate like this, or did you use some other method and got this answer?
Use the same, but I think I
Yeah, there might be some miscalculation. So I think the right answer would be option C. You can verify your calculation again. Now question 6 is very small Bayesian network is given here. F and C, these are the only two variables, and there is a directed edge from F to C, and these three probability values are given: probability of F, probability of C given F, and probability of C given F complement. So this is probability of C given F complement, so 0.3. So these three values are given. You have to compute these two probability values, probability of C and probability of F given C, using this small Bayes network and these three probability values given here. Aditya Chauhan has written option C, 0.254 and 0.024. Mishti Pandey is saying option A, which is 0.35 and 0.23. Anyone else? So this question is not very difficult. So probability of C, this is probability of C given F into probability of F plus probability of C given F complement into probability of F complement. So C given F is given 0.8, probability of F is given, and C given F complement is given as 0.3, and probability of F complement is 1 minus probability of F, which is 0.9, and if you compute this, it would be 0.35. And then the second probability value is probability of F given C. For this we have to use Bayes theorem. So probability of C given F into probability of F divided by probability of C. Probability of C is already calculated, 0.35, and so for the numerator, probability of C given F is 0.8 and probability of F is 0.1 divided by 0.35, and if you calculate this thing, it would be 0.23. So option A is the correct answer. Yeah, so I've got 4 other answers in the chat. Pratik, Raghav, Aditya and Suresh all have written option A. Yeah, option A is the correct answer, 0.35 and 0.23. Consider the Markov network or the undirected Bayesian network in this figure. So there are no directions in these edges. So a very similar question we did in this live session. The first question that had a very similar looking Bayesian network, but that was a directed Bayesian network. Here this is an undirected Bayesian network, so it is also called Markov network. So the edges are not directed here, and 2 claims are made by 2 students. So first student claims that probability of A given B equals probability of A, and second student claims that probability of A given B and C equals probability of A given C. So you have to find out whether both the statements are true or one of them is true or both are incorrect. Pratik Tiwari is saying option B, which is student A is correct, student A is incorrect, and student B is correct. Okay. So for undirected Bayesian networks, the conditional independency checking is much simpler than in case of directed Bayesian networks. Here you just have to check whether there is a path from A to B, or the nodes that are for which you want to find out the conditional independency, and the nodes which are given or known are in that path or not. So you don't have to use those deseparation rules, which are very much complicated, and it takes time to even understand and check those using those deseparation rules. In case of undirected networks, it is much simpler. So first claim is probability of A given B equals probability of A. So that means we have to check whether A and B are conditionally independent or not. No evidence is given. A and B, whether these two are conditionally independent or not. So there is a path from A to B via C, and C, if C was given, in that case this path would have been blocked by C. C is not given, so this path is not blocked. So if this path is not blocked, there is a path from A to B, so A and B cannot be conditionally independent. So this first claim is wrong. Second claim is probability of A given B and C equals probability of A and C. So this says that we have to check for A and B whether these two are conditionally independent given C. So there is this path from A to B via C, and C is given. So if C is given, C blocks that path from A to B. So as C blocks that path, A and B cannot be, there is no path from A to B anymore. C blocks this path, and if there is no path from A to B, so in that case A and B are conditionally independent. So this is what the second claim is, that A and B are conditionally independent given C. So second claim is right. So correct answer would be option B. Student A is incorrect, student B is correct. Yes, option B is the correct answer. Which of the following algorithms are not ensemble learning algorithms? This is the question 8. Which of the following algorithms are not ensemble learning algorithms? There are 4 options: random forest, adder boost, gradient boosting, and decision tree. Pratik is saying option D, decision trees. Suresh is also saying option D. Yes, so correct answer is option D, and this is the only correct answer. It is written that multiple options may be correct, but all the 3 other options, random forest, adder boost, and gradient boosting, all 3 algorithms are ensemble learning algorithms, and decision trees are not ensemble learning algorithms. These are individual classifiers. So option D is the only correct answer here. Now question 9. So a Markov network or undirected Bayesian network is given here, which contains 8 nodes and several edges between these nodes. Which of the following variables are not in the Markov blanket of variable 4 shown in this figure? So for the variable 4, which is here, which nodes are not in the Markov blanket of this variable 4? Pratik says 5 and 7, option D and G. Shankalal is also saying option D and G. Raghav is saying Markov blanket means immediate neighbors. Yeah, Markov blanket of a node is the set of nodes which are neighboring nodes to that node. So the correct answer would be 5 and 7, option D and G. So for 4, if we try to find out the Markov blanket of 4, which are the neighboring nodes to 4? 1 is a neighbor, there is an edge. 2 is a neighbor, 3, 6, then 8. So these are the nodes 1, 2, 3, 6 and 8. These are the nodes which are direct neighbors of this node 4. So the only 2 nodes which are not direct neighbors, 7 and 5. So there is no direct edge from 4 to 7 or 4 to 5. So that means 5 and 7 are not in the Markov blanket of node 4. So these 2 are the correct answers. So consider this Markov random field or the Markov network, undirected Bayesian network. Which of the following nodes will have no effect on H? H is this node. Which of the nodes will have no effect on which of the following nodes will have no effect on H given the Markov blanket of H? Pratik Tiwari is saying CEF, Shankar Lal is saying CEF. Okay. So the correct answers are C, E, and F. So the question is that which of the following nodes will have no effect on H given the Markov blanket. So for H, if we try to find out the Markov blanket, so these are the immediate neighbors: A, B, D, G, J, I. So these are the nodes that will be in the Markov blanket of H. So all the other nodes that are not in the Markov blanket of H will have no effect on H given the Markov blanket. So if Markov blanket nodes are given in that case, all the other nodes have no effect on them. Which are the other nodes? So F, E, and C, these three nodes are not there in the Markov blanket of H. So these nodes cannot affect H if the Markov blanket of H is given. So that's why C, E, F, these are the three correct answers here. Now question 11. So this Bayesian network is given here, consisting of 7 nodes and several edges, directed edges. This, and you have to find out the joint probability distribution of all the variables in the above network. Suresh Kumar Singh is saying option A. Shankar Lal is also saying option A. Pratik Tiwari is also saying option A. So all three answers in the chat are option A. So the correct answer is option A. So the joint probability distribution of all the variables basically means we have to find out the probability distribution of S1, S2, S3, S4, D1, D2, D3. So joint probability distribution of all the variables in this diagram or in this Bayes network. So to find out the joint probability distribution, first we need to find out the nodes that are not dependent on any other nodes. So this d1, d2, d3, these three nodes are independent of any other nodes. There are no incoming edges to these three nodes. So we can simply write probability of d1 into probability of d2 into probability of d3. Then for each of the other nodes, we have to check which are the nodes that node is dependent on. So S1 is dependent on only D1 because there is a directed edge from D1 to S1. So for S1 we have to write probability of S1 given D1. For S2 there are two incoming edges, one from D1, another from D2. So for S2 we have to write probability of S2 given D1 D2. Now for S3 there are two incoming edges from D1 and D3. So for S3 we have to write probability of S3 given D1 D3. And finally for probability of S4 there is only one incoming edge from D3, so probability of S4 given D3. So this is the joint probability distribution for all the variables in this Bayesian network, and option A is the correct answer. So these are the questions that I planned to discuss in this live session. And now if you have any questions or doubts regarding any of the questions discussed in this session, you can ask me now. So is there any questions or doubts?
Yeah, I have one. It is regarding the undimensional. Where you mentioned in the lecture about MRC in that you mentioned that this is the factors that we consider can be expressed as the exponential of the energy evolution.
Yeah, you can ask that question in the discussion forum, because the regular TAs would be much better to answer your query there. It would be difficult to answer your doubt in this live session regarding that part. So if there are no other questions or queries, then we can end this meeting here. Thank you everyone for joining. We will again have a live session next week.